So we're going to reconstruct this normal curve one more time just to make sure. Notice we shouldn't go down and touch. We know right in the middle is the mean and the median. We measure things. Our measuring stick is the standard deviation. So right now we're going to go from the mean, we're going to go one standard deviation above and one standard deviation below. And we know that 68% of the people fall within that. 34 on one side, 34 on the other. Then we have two standard deviations above and two standard deviations below. And we know a total of 95% fall in that region. 68 made up the middle part of that region. And so when we look at how much data this is going to be, we need to subtract these from each other, and we get 27%. And so we know then that each region here is 13 and a half people would land if this was out of 100, and 13 and a half people would land below. And then we continue this and we can find that this is 2.5 space and this is 2.5. But what I'm worried about is if somebody tells me I'm one standard deviation above, where am I at? All of these people are below me. So 50 gets me to here plus another 34 is I'm at the 84th percentile if I'm landing in that location. Then I know that there are 13 and a half in this, and if I add that, I get 97 and a half. And lastly, if I am 3 standard deviations above, basically we say you're at the 100th percentile. Going the other direction, this is 50, I drop down 34, that's 16%. It's the 16th percentile, and I drop down another 13 and a half, I'm at the 2.5 percentile. So what we like to do is we use this curve to compare. So if I went in and I'm getting my cholesterol checked, and the average female cholesterol is 170. I'm not sure how they measure that, but 170 is my cholesterol level. And the standard deviation is 10. And I go in and I have my cholesterol is at the 190 range. So where does that tell me I'm at on this curve? And this is how the doctor will tell, do you have high blood pressure, high cholesterol, and so forth. Remember, this was 170 in this situation. And I went, standard deviation was 10. And so 190, well, let's see, one standard deviation is equal to 10. So that puts me at 180. Another 10 puts me at 190. I'm in the 97.5 percentile, not a place I want to be if that is my cholesterol. That's telling me my cholesterol is high. And so that's how they tell what goes on. So you can compare and generalize a lot of things based upon this curve. Another example is I'm 5'6". That's average. All right. So if you happen to be a female that is 6 feet tall, how far away from average are you? Where are you at in a percentile? Well, we need to know the standard deviation. And if the standard deviation is 2 inches, how far above the center are you? Well, if you look at 5 feet 6 inches and you want to go to 6 foot, that's a total of 6 inches in difference. If I take 5 feet 6 inches and take off 6 foot, you need to remember that inches isn't out of 10, it's out of 12. So I have 6 inches, and we're going to divide that by the standard deviation. I am 3, or you would be, if you were 6 feet tall, 3 standard deviations above. You would land right here on that curve. So let's try a couple test scores and see what happens. The average on the test score was 80 and the standard deviation was 2. Your score was 84. Where are you on this curve? Well, there's a simple formula that will do that for me. My score was 84. The center was 80. I was 4 steps. Oh, no, I was 4 as a score above, not steps. I was 4 as a score above. The step size, the unit of measurement, is 2 in groups of 2. So if I divide this 4 by 2, I was 2 steps above. So if I look, I landed right here. I was in the 97.5 percentile. Not bad. Let's try in English. the average score was a 40 and the standard deviation was 5. And I scored a 48. So my score was a 48. The average was a 40. So I know I am, as a score, 8 above. What does that 8 mean? Well, I want to generalize it into the relation of everybody else. So if I divide this by 5, 8 divided by 5 is 1 and 3/5, which turns into 1 and 6/10 if I find a common denominator, because I'm trying to get my base 10 so that I can write a decimal. I'm 1.6 standard deviations above. Well, would you rather be 2 standard deviations above or 1.6? In other words, in which test did you score better? You scored better when you were 2 steps. The 1.6 is about in this region. So you know you're between 84 and 96. We actually have tables that will help us find that exact value of where we fall in terms of a percentage.